Now take this question that has been asked in ES 2016. The graph of a network has number of branches B is equals to 7. Okay, a number of nodes N is equals to 5 and we have to find number of independent KVL and KCL equations. We know that number of independent KVL equation is equals to the number of link, that is equals to the branches minus number of twigs. Okay, and what is total number of branches? That is equals to 7 minus twig is equals to n minus 1. So that is equals to 7 minus what is number of nodes? That is 5 minus 1. So we get 3. Okay, now what is number of KCL equations? Number of KCL equation is equals to the number of twigs. Okay, number of twigs, and that is equals to n minus 1. So that is equals to 5 minus 1 is equals to 4. Now take the question that has been asked in ES 2001. If total number of branches in a graph is equals to 10 and number of nodes is equals to 7, then we have to find the number of independent loops. Number of independent loops means we have to find the number of links, and we know that number of link L is equals to the branches minus number of twigs. Okay, so we get number of branches are 10 and twigs are equals to n minus 1. So 10 minus 7 minus 1, that is equals to 4. So here it is the answer. Now take this question that has been asked in GATE 2002 and ES 2017. If a graph has n number of node, B branches, and then we have to find number of links. Okay, so number of link is equals to branches minus number of twigs, and that is equals to B minus n minus 1. So we get B minus n plus 1. So this is the answer. Now you can see how questions are repeated on a similar concept. Okay, not only on similar concept, how questions are repeated on the same formula. So this is very important formula. Okay, now take this question that has been asked in ES 2017. We have to find which of the given statements are correct. Okay, first, a tree contains all the nodes of a graph. This is correct because here suppose this 1, 2, 3 forms the branches of a tree, then we can see that this tree includes all the nodes of graph. So first is correct. A tree shall contain any one loop? No. A tree should not contain any closed loop. So this is wrong. Okay. And every connected graph has at least one tree. This is also correct. So here 1 and 3 are correct, second is not correct. Now take this question that has been asked in ES 2014. A graph in which at least one path exists between any two nodes is called. So a graph in which all the nodes are connected by a particular path, then such graph is called connected graph. Okay. Now take this question that has been asked in GATE 2001. Here in this question, a connected graph of network for nodes greater than 2, the graph of a network must have branches for one or more closed path to exist, can have unlimited number of branches, can only have at most n branches, can have a minimum number of branches not decided by n. Okay, now we have to choose the correct option among these four. So to check this, let's take a tree of graph. Okay, and we know that tree of a graph includes all the nodes. Suppose it has 4 nodes. Okay, so number of nodes is equals to 4 and number of twigs, that is equals to n minus 1, is equals to 3. So here it can have unlimited number of branches. It cannot have unlimited number of branches. Okay, can only have at most n branches. That is also not correct because we can add a link here, add a link here, then this number of branches becomes greater than number of nodes. So this is also not correct. Can have a minimum number of branches not decided by n. This is also not correct because number of nodes decide the number of branches. Okay. Now, how this first option is correct? Suppose for at least one closed path, we need one link. Okay. If I take this link, okay, then we get one closed path. So to have minimum one closed path, we add a link here. On adding this link, the total number of branches in a tree B is equals to 4, and that is equals to the number of node n, that is 4. So we can say that the graph of network must have n branches for one or more closed path to exist. So you can easily check this option. Okay. Now take this question that has been asked in IES 2005. Here we have to find which statement is not correct. First is a tree contains all the vertices of a graph. So this one is correct. Okay. Now second is a circuit contains all the vertices of a graph. Here it is not correct because a circuit means a closed loop, or a closed loop need not to contain all the vertices of a graph. Okay, so this is not correct. The number of F circuit is equals to the number of codes. So number of codes means number of links, and we know that number of fundamental circuits is equals to the number of links. So this is correct. Okay, and the fourth one is there are at least two edges in a circuit. This is also correct. Okay, so only option B is not correct. Now take this question that has been asked in IES 2003. The number of edges in a complete graph is equals to. So here you must remember this formula, because questions may directly ask from this formula in the upcoming IES and GATE exam. So this formula is number of edges in a complete graph is equals to, here I write this formula, that is equals to n minus 1 upon 2. Okay, so remember this formula. Now take this question that has been asked in GATE 2004. Which of the following is not tree of given graph? Okay, this graph is given and we have to find which of these four options is not tree of a graph. We know that the tree of a graph must include all the nodes of the graph. So here all these four options include all the nodes. But second point is tree of a graph should not have a closed path. Here in this option B we can see that this has this closed path. So option B is not tree of this graph. Now take this question that has been asked in IES 2017. Here this graph is given and we have to tell which of these four options are correct, or which of these four options are associated with this graph. So first is this is regular graph, second is this is connected graph, third is this is complete graph, and fourth is this is a non-regular graph. Okay, so here answer is it is a regular and connected graph. Why? Because a regular graph is a graph in which each vertex has same number of neighbors, and here each vertex has 3 neighbors. Here it has 3, here it has 3, here it has 3, here it has 3. Okay, so each vertex has 3 neighbors. That's why it is a regular graph. Now what is connected graph? A graph is connected when there is a path between every pair of vertices. So it is a connected graph. So here This 1 and 2 are associated with this graph.
If you got the knowledge and concepts from this video, then please like the video and subscribe the channel. You can give your views and ask any questions related to this topic in comment box. Also share this video with your friends because sharing is caring. Don't forget to press the bell icon to get the notification of my upcoming videos. Thank you.